right, so in example 3, we're going to talk about some different ways of selecting some different combinations of DVDs and then use those combinations to solve some probability problems. Again, we're going to be using our combinations. We're going to be bringing up complements. We're going to be thinking about multiplying different combinations together. So this is going to kind of tie everything that we've seen, or not everything, but a lot of things that we've seen in this chapter together. So Jennifer has 4 Scooby-Doo DVDs, 5 Magic School Bus DVDs, and 3 Bob the Builder DVDs. If Jennifer randomly selects 4 DVDs for her children to take on a road trip, determine the probability that no Scooby-Doo DVDs are selected. Right, so our first probability that no Scooby-Doo DVDs are selected. Right. All right, so if we think about this, we have a total of 4 Scooby-Doo DVDs, 5 Magic School Bus, and 3 Bob the Builder DVDs. So in some cases, it might be easiest to start with our denominator. So if we add those up, 4 plus 5 plus 3, well, that's going to give us a total of 12. So we are selecting 4 out of the 12 DVDs. So I'm just kind of write this out in a couple of steps here. And that is going to give us 12C4 is 495. So that's going to be our denominator. All right, our numerator. Right, no Scooby-Doo DVDs are selected. So if we eliminate the 4 Scooby-Doo DVDs that we have 5 Magic School Bus, 3 Bob the Builder. That gives us a total of 8 left. Right, so 8C4 is equal to 70. 70 over 495, they're both divisible by 5. So if we write this in as a fraction in lowest terms, we're going to get 14 out of 99. So the probability that no Scooby-Doo DVDs are selected is 14 out of 99. All right, this example continues at the top of the next page. All right, so what is the probability that at least one Scooby-Doo DVD is selected? Remember, whenever we see the probability of at least one, we are using our complement. So we are going to do 1 minus our probability of none. Right, our probability of none we just found in part A. So 1 minus 14 over 99. Right, we subtract, we get 85 out of 99. So the probability that at least one Scooby-Doo DVD is selected is 85 out of 99. All right, then for C, 2 Scooby-Doo DVDs and 2 Magic School Bus DVDs are selected. Right. So 2 Scooby-Doo and 2 Magic School Bus. All right. All right. So our total number of possible combinations is the same as it was in A. We still have 12 DVDs to choose from. So our denominator is going to be 12C4, which is 495, just like it was in example A. Right now, we have 2 different possible things that could happen here, or 2 different things that we're looking at. We're looking at selecting 2 Scooby-Doo DVDs and 2 Magic School Bus DVDs. Right, so 2 Scooby-Doo, right? We have a total of 4 Scooby-Doo DVDs. So we're going to take 4C2 for our Scooby-Doo. And then for our Magic School Bus, there were 5 Magic School Bus DVDs. So we're going to take that times 5C3, or excuse me, 5C2, because we're still selecting 2. All right, so 4C2 for our Scooby-Doo gives us 6. 5C2 for our Magic School Bus gives us 10. If we multiply these, this gives us 60 over 495. Again, they're both divisible by 5. And then they're actually even divisible further than that. if we reduce this into lowest terms, we end up eventually getting 4 out of 33. Because if we divide both our numerator and denominator by 5, we would get 12 over 99, which then we would divide those both by 3 to get the 4 over 33. So as we're working through these, again, pay attention if you're being asked for answers as reduced fractions or as decimals. Make sure that you are carefully coming up with the correct combination for your denominator, and either combination or multiply the different possible combinations needed for your numerator.